Good day, everyone. Let's proceed to the next chapter, chapter 3. Chapter 3 is equilibrium of particles. Equilibrium of particles. Okay. So at the end of the chapter, you, the students, should be able to know the conditions of equilibrium for a particle, both coplanar and non-coplanar. Understand and use the concept of free body diagram to analyze equilibrium problems and solve problems on equilibrium of particles in 2 dimensions and in 3 dimensions. Okay, so conditions for equilibrium of a particle. Number one, let's define first what do we mean by equilibrium. Okay, it is the term used to designate the condition where the resultant of a force system is zero. So take note of this. We have in the previous chapter, chapter 2, we have dealt with force system resultants. So these are forces in concurrent forces in 2 and 3 dimensional force systems. Okay. So for a particle to be in equilibrium, the resultant should be equal to 0. A particle is said to be in equilibrium if it remains at rest, if originally at rest, or has a constant velocity if in motion. So uh, this would be the Newton's first law, law of inertia. Okay. To maintain equilibrium, it is necessary to satisfy Newton's first law of motion, which requires the resultant force acting on a particle to be equal to 0. This condition in mathematical form is, so this would be the mathematical form of the Newton's first law. So the resultant of the forces should be equal to 0. So that if we have a system of forces, a lot of forces acting on a certain body or particle. So for the particle or the body to be in equilibrium, the resultant should be equal to 0. Okay. So for coplanar force systems, if a particle is subjected to a system of coplanar forces that lie in the xy plane, the forces can be resolved into ij components for equilibrium. For equilibrium, these forces must have a sum of 0. So if we have a coplanar force systems, when we say coplanar, that means these are forces that lie on the same plane. In this example, we have the xy plane. Now, so that if we have a lot of forces and we have resolved those forces into components along xy axis, so for the particle to be in equilibrium, then the summation of forces along the x-axis, so all forces that lie along the x-axis should be equal to 0. Its resultant, yung summation niya. And then summation of forces along the y-axis, all vertical forces should be equal to 0. Okay, so that would be the condition for ito, for coplanar force system. So summation of forces along x is equal to 0. Summation of forces along y is also equal to 0 for a particle to be in equilibrium. Okay. And for 3 dimensions, of course, mag-add lang tayo ng isang axis. So summation of forces along the z axis should be equal to 0 for a particle, for a body to be in equilibrium. Okay. So these equations mean that the sum of the rectangular components of the force system in any direction must be 0. These equations can be used to determine two unknown quantities for if we're dealing with the coplanar force system. Okay. 3 kapag we have the forces in 3 dimensions. No? Okay. So, yun. So, yun lang ang ating i-apply sa chapter na ito. Okay. So, we're just going to apply the Newton's first law, okay, law of inertia. And later on, we're going to apply also the third one, the Newton's third law, no? Okay. So next, we discuss the concept of drawing free body diagrams. So a free body diagram, or FBD, it is a drawing that shows the particle with all the forces. So the particle with all the forces known and unknown that act on it. So drawing natin yan. So we're going to simplify. So for example, we have a particle or a body subjected to external forces. Ano? So we're going to simplify, redraw the situation. No? So we're going to simplify natin yon. So we have the particle. Idrawin lang natin yung particle and all the forces that act on it. Okay? So we call that the free body diagram. So in drawing a free body diagram of a body or particle, certain assumptions are made regarding the nature of the forces or reactions exerted by other bodies on the body of interest. Three common assumptions are the following. So we have three assumptions here. So we're going to identify, or assume the reactions exerted by other bodies, okay, of on the body of interest. Okay, so maybe a particular body in contact siya with another body. Okay, so what would be the reaction of the other body relative to the body we are analyzing, no? So ito. Number one, so a particle or a body might be supported by springs. So springs, no? Ano yung spring? I believe you have seen springs already. Sometimes it is used sa paggawa ng ballpen. Mga ballpen na may spring, yung mga sasakyan natin, yung motor, yung mga four wheels natin, may mga spring. Okay? Saan pa ba yung na-apply yung mga spring? Sa doors. Sometimes sa doors. Yung spring natin. And many other applications ng spring. So the magnitude of the force exerted on a linearly elastic spring. So take note, this is basically an assumption. Linearly elastic spring, which means that the elongation of the spring, elongation or compression, elongation, kasi the spring might elongate, it might also be be compressed, no? So depende sa external force that would be applied on the spring. So this is an assumption, linearly elastic spring. Ibig sabihin yung magnitude ng force is directly proportional to the elongation of the spring, ano? So which means there's a direct relationship between the force exerted and the elongation of the spring. So that's our assumption. So that's why we call it a linearly elastic spring, which is commonly the case when we analyze springs. But there are, of course, other more complex situations. No? Sometimes the behavior is not linear. No? The behavior is not linear. Sometimes. And that would make the analysis more complicated. No? Okay, so the force exerted on the spring is equal to K times S. K here is the stiffness or spring constant. So it's an intrinsic property of the spring. So given yun, so bawat spring, bawat klase ng spring ay merong specific na spring constant. So the spring constant defines the elasticity of a spring, and S here is the deformation to generalize the term. It's the deformation or compression of the spring measured from its unloaded position. So yan, ito yung ating figure. So S would be the elongation or deformation of the spring here. L sub O is the original length or the undeformed length of the spring, and the total length of the spring is the sum of the two, the undeformed length and then the elongation of the the deformation of the spring. Okay, so L minus L sub O, S is equal to L minus L sub O, where L is the stretched length and LO is the undeformed length. Okay, so that's spring. So we'll have some examples later on. And then we also have cables and pulleys. Cables or the like can support only a tension or pulling force, and this force always acts at the direction of the cable. No? It is assumed that a cable has a negligible weight and it cannot stretch. So although in reality, of course, na-stretch yung cable, ano, may certain elongation, but since we're dealing with rigid bodies, I have mentioned this during our introduction, that we're going to deal with rigid bodies, which means we're going to neglect the deformation of bodies being analyzed, except of course for spring, no? Kasi we're going to consider of yung elongation dito, no? And then for cables, cables are tension. It can tension structures, no? It can support only a tension or pulling force. So, hindi mo pwedeng i-compress yung cable, ano? Ayan. So the tension force developed in a continuous cable which passes over a frictionless pulley. Again, this is an assumption. The pulley is frictionless. Okay. Must have a constant magnitude to keep the cable in equilibrium. Hence, for any angle theta given in this figure, may tayong figure dito. Any angle theta, the cable is subjected to a constant tension T throughout its length. So if this is T, no, and the cable runs through this pulley, frictionless pulley, that means this is also T. So, hindi nagbago yung value ng tension natin. If it runs through this pulley, no, of course, kung may frictionless pulley tayo dyan. Okay. Next is, ito. Smooth or frictionless surfaces. Smooth or frictionless surfaces. If a surface of contact at which a force is applied by one body to another body has only a small degree of roughness, it may be assumed to be smooth or frictionless. Therefore, the action or reaction of the body on the other is directed normal. So take note. Directed normal to the surface of contact. Okay, normal means perpendicular. Tulad nito, meron tayong body na it rests on a surface here. So the reaction of the surface here, yung reaction niya dyan, Newton's third law, no, is perpendicular to the body being considered. So, ganun yung reaction niya. So, if this body rests on this smooth surface, the reaction of that smooth surface is perpendicular to the body being considered. Okay. So, when applying each of the two equations, so we're dealing with coplanar force systems here, two dimensions, no? When applying each of the two equations of equilibrium, we must account for the sense of direction of any component by using an algebraic sign which corresponds to the arrowhead direction of the component along the x or y axis. Okay. So, importante that we account for the direction of any component, no, of the force. Okay, because very important yan sa pag-resolve ng forces. Okay. It is important to note that if a force has an unknown magnitude, then the arrowhead sense of the force on the free body diagram can be assumed. So if we do not know yung may unknown, may force, ihanap natin, hindi natin alam yung direction niya, okay, we can assume, okay, we can assume the direction of that particular force. And if the solution yields a negative scalar, so if later on, na-solve natin negative yung result, this indicates that the sense of the force is opposite to that which was assumed. Okay, so ibig sabihin, mali yung assumption natin, mali yung direction na na-assume natin, so we can correct it later on. So kapag malalaman natin na wrong yung assumption ng direction kapag negative yung result. No. Okay? So, pag negative yung result, that means wrong yung assumption ng direction. Correct yung value, yung magnitude niya, but the direction is wrong. Then you can correct later on. Okay? So, you can assume any direction and correct it later on kapag mali yung ating na-assume na direction. Okay? So, yun yung common na assumptions natin. Okay? So, yun. Okay, let's have an example. Number 1, a force P is supported by two cables that are tied together at C as shown. Knowing that the maximum allowable tension is 800 newtons in cable AC and 1,500 newtons in cable BC, determine the magnitude of the largest force P and the corresponding value of alpha, its direction from the x-axis. Okay, so this would be our situation here. So meron tayo, P might be weight something or another, I don't know. So P is supported by these two cables. So P might be a body that has a weight, P, or parang ganun na na represent lang siya as a force, So yan yung P is supported by cables AC and this should be AC and CB or BC. Okay. Okay, so first is we need to draw the free body diagram, FBD. Free body diagram natin. So this is the particle being considered. Okay, so let's i-cut natin yung cable. So this is point C. Lagyan natin ng Cartesian. Okay, ayan. So this is point C. So meron tayong tension dito. Tension. So P is supported by cable. So ano yung reaction ng cable natin? So yung cable natin, since tension yan, so parang hinihila niya. So ito yung P, ito yung line, ito yung force P natin. Okay, it could be a weight of a certain body or material. Okay. And then, of course, yung cable natin, since may weight dyan, ang reaction ng cable natin is parang hinihila niya pa ganun. Yung weight natin o yung force P. So, ganun din sa cable AC. Parang hinihila niya yung particle or yung body pa ganun. So, na-stretch siya pa ganun. Okay, so parang naghihilahan tong mga forces na ito. Ito, so hinihila ng cable CB or BC pa ganun. Humihila naman ng cable AC pa ganun. So the direction of, obviously, yung direction ng tension natin, yung force, since papalitan natin. So this is the particle, ito yung tension, palitan natin ng force dito. Okay, so this would be BC. And then we also have a tension here. Ano ba to? Galing. Ayan. This is AC. Alright. So AC yan. And we have force P here. We don't know its angle of its direction. We are going to solve for its direction from the x-axis alpha. Okay. So yan yung ating free body diagram. Of course, not forget to include also yung other important na parts. That would be the angle of inclination ng BC. Okay. So ito yung cable BC natin. This is 50 degrees. So basically, if 50 yan, opposite angles are equal from geometry, ano? This is also 50 degrees. Ito, this is also 35 degrees. So this is 50 degrees. This is 35 degrees. BC can have a maximum. Allowable tension natin is 15 newtons, 1,500 newtons. And AC can have a maximum of 800 newtons. Ayan. And then we are to solve for P here. So using the conditions of equilibrium, since this is a concurrent coplanar forces, 2 dimensions lang ito. So for this particle to be in equilibrium, the summation of forces along x-axis or horizontal direction should be equal to 0. Summation of forces along y should also be equal to 0. Okay, so resolve natin ito into their x and y components, BC, AC, and P. So let's start with summation of forces along x. Summation of forces along x-axis is equal to 0. That is equal to, so lahat ng x components. So let's start with P. Ano ang x component ng P? X component of P is ito, adjacent side natin, P, or let's say PX na lang. Sorry. It should be PX. Okay. Ang direction niya is to the left yung kanyang direction, which means negative, no, yung ating direction. So negative PX plus cable BC natin. Cable or force BC is 15. X component niya is 1,500. Adjacent side. Cosine of 50 degrees. Positive siya since to the left yung component. So take note, ito yung component ng BC. So this is BCX. This is BCY. This is ACX, ACY. This is PX, and this is PY. Alright? So, ayan. Let's continue. So, this is the BCX. Now, ACX naman tayo. So, obviously, to the left siya. So, minus 800 adjacent side ng 35 degrees na angle natin. So, that's cosine 35 degrees. Okay. That should be equal to 0. That should be equal to 0. So, 0 is equal to, so minus, i-rewrite lang natin, minus px plus 15 cosine 50 degrees minus 800 cosine of 35 degrees. Okay, so this would be our equation for summation of x along the summation of forces along the x direction. Okay, and with this we can solve for p, or px I should say. So we have one unknown in the equations, and we can solve for the value of px. So from this, px is equal to 308.86 newtons. So that is the x component of p. Okay. Next is we solve for the y component of p. So how do we solve that? We summate forces along the vertical direction, or y-axis, and equate that to 0. Ayan. So with that, so let's start with py, the y component of p directed downwards, so minus py. And then we have bc is upwards, so positive, so plus 1,500. Sine na ngayon, opposite side niya, sine of 50 degrees. Okay. And then we also have the y component of AC, which is upwards also, so plus, so positive, 800 sine of 35 degrees. Then we equate that to 0 since the particle or the body is in equilibrium. Okay, so with this we can solve for py, p sub y, or the y component of p. That is equal to 1607.928 newtons. So ito yung value ng px and py natin. We can simply solve for p. Okay, so yan na. So positive yung results nito, which means we have assumed the correct direction. So that's equivalent. So p is equal to the square root of px squared, the quantity equal px squared plus py squared. So px then by so the yun pala, sorry. Gustulat ako, hindi pala sali sa video. Ayan. So P is equal to what is P? 1637.323 Newton. So that is the value of P, and then we can solve for alpha, the direction of P from the negative x-axis, using tangent function. So alpha is equal to the arctangent of remember, ito yung ating, baka nakalimutan nyo ulit. So this is px, this is py, okay, for parallelogram method. This is P, this is alpha, okay, this is also px, and this is also py. So tangent, opposite over adjacent. So we have py all over px. So arctangent of py all over px. So py is 1607.928 over px, which is 308.86. So the direction alpha is equal to 79.13 degrees. So we have P and we also have alpha. Alright?